Welcome to tonight's video on section 6.6 talking about vectors. A vector is a directed line segment we'll draw a vector PQ here. It's a directed line segment that has an initial point, and that initial point is where the vector starts. So here, this is the initial point P. That's where the vector starts. And then the terminal point is the point which the vector goes towards. All right, so this Q would be the terminal point. The magnitude of the vector is the distance from the initial point to the terminal point. And when we talk about magnitude, we write it like this. That is magnitude. That means magnitude of the vector. Two vectors are considered equal if they have the same magnitude and direction. So here we have a diagram, and we're going to show that vector u is equal to vector v. So first we have to find the magnitude of u, and that's by doing the distance formula. So we go 3 minus negative 3 squared plus 0 minus negative 3 squared. 6 squared plus 3 squared is 36 plus 9, which is 45. And then v is 0. Actually, sorry, we'll do it this way. We'll go 3 minus 0 squared plus 6 minus 0 squared. So we get 3 squared plus 6 squared, which is the square root of 45. So we've proven that they have the same magnitude. To see if they have the same direction, we're going to find the slope. And if they have the same slope, that means they have the same direction. So the slope of vector u, we go, remember it's y2 minus y1, so 3 minus negative 3, over 0 minus negative 3. So it's 6 over 3, which is 2. And then the slope of vector v is 6 minus 0 over 3 minus 0, so it's 6 over 3, which is also 2. So basically, u is equal to v since they have the same magnitude and direction. All right. So when we multiply a vector by any number, so we can have a vector here. Like, let's say we have a vector, and this is v. When we multiply it by a number, it just makes it longer, but in the same direction. So for example, let's say that was 2v, right? Or if I multiply it, let's say it goes in the same direction but shorter, let's say that's 1/2 v, right? But notice anytime I multiply it by a positive number, it changes the magnitude but not the direction. But a negative number would change the direction. Like let's say that's -3/4 or like -3/2 v. So notice it changed the magnitude and the direction because it was multiplied by a negative. So, scalar multiplication, a scalar is just a number that we multiply by a vector. And the vector that when we multiply by the scalar will have the magnitude of that scalar times the magnitude of the original vector. A resultant vector. Well, a resultant vector is when we either add or subtract. So if we have two vectors, like for example, vector u here and vector v, all right, and we add them together, the resultant vector is here. This is u plus v. That's basically what the resultant vector is. It goes in the same direction and it completes the triangle. U minus v, well, if you have vector u going this way and vector v going that way, well, negative u means it goes in the opposite direction this way, and negative u would also be going that way. So v minus u would be the vector that connects them there. So that would be the resultant vector of v minus u. Well, next we're going to talk about vectors in the coordinate system. And here's the y-axis, and here's the x-axis. And the vertical axis here, the y-axis, that is considered the j vector, which is 1 unit in length here. And then we have the I vector, which is 1 unit in length on the x-axis. So when we write vectors, we are going to consider it in terms of I and j, meaning the horizontal and vertical vectors, I and j. So if I go this vector here, and it's ai plus bj, that means that it was from the point a comma b, and that means it went up b and over a on the horizontal axis. So for example, if I give you a point 3i minus 3j, and I say to sketch that vector, well, remember I is the horizontal, so that means you go 1, 2, 3 this way, and j is the vertical, but it's negative, so you go down 3. So that means it's going to go to the point 3, -3, and there's your vector. So this is 3i minus 3j. So I is horizontal, j is vertical. To find the magnitude of this vector, we're just going to square the components. So we go 3 squared plus -3 squared. So we go 9 plus 9, which is the square root of 18, which is 3 rad 2. So that would be the magnitude. All right. So here we go. So here we're going to write these points in terms of a vector AI plus bj, AI plus bj as the vector. So what we have to do first is we have to take and subtract the x's. So we have negative 2 minus 3 I plus, and then we subtract the y's, 5 minus negative 1 j. So it's negative 5i plus 6j, and that would be our vector in terms of I and j. Here's another one. We would go 2 minus negative 1i plus 7 minus 3j. So it's 3i plus 4j. That is our vector. We can do operations with vectors. We can add them. So if I have a vector v that's 7i plus 3j and a vector w that's 4i minus 5j, if I add them, I add the a's together. So 7 plus 4i plus I add the j terms, 3 minus 5j. So it's going to be 11i minus 2j. Whereas v minus w, I'll do the same thing, except now I subtract the a's. So I go 7 minus 4i plus 3 minus negative 5j. So I have 3i plus 8j. All right, I can also multiply by a scalar, a vector. A scalar is just a regular number. So if I go 8v, I'm going 8 times 7i plus 10j. So that gives me 56i plus 80j. And if I look at part B, it says to multiply by negative 5. So I multiply by negative 5. And I get negative 35i minus 50j. All right, moving right along. Here's some operations again. So when we have 4 times v, so I have to multiply 4 times v, minus 2 times w. So I distribute the 4, so I get 20i plus 16j minus 12i minus 18j. So now I'm subtracting. So remember, I take and I subtract the i's. So I get 20 minus 12i plus 16 minus 18j. So I get 8i minus 2j. Sorry, let me redo this because I forgot to distribute this negative sign in here. So it's 20i plus 18i plus 16j, or sorry, 20i minus 12i plus 16j plus 18j. So it's 8i plus 34j. I forgot to distribute the negative sign first. just like algebra. So 6v minus 3w. So 6 times 7i plus 3j minus 3 times 4i minus 5j. So it gives you 42i plus 18j. And you can distribute the negative with the 3. So a minus 12i plus 15j. And then just combine like terms. So I get 30i plus 33j. A unit vector is a vector whose magnitude is 1. So to find a unit vector that has the same direction as the vector that you're given, you can take the vector and divide it by the magnitude. So if I want to find a unit vector in the same direction as 5i minus 12j, I have to first find the magnitude of the vector. So I take the square root of 5 squared plus negative 12 squared. 25 plus 144 is 169. The square root of 169 is 13. So I take 5i minus 12j and divide it by 13. So it's 5/13 I minus 12/13 j. That would be the unit vector in the same direction as 5i minus 12j. Here, same thing, find the magnitude. So you take the square root of 4 squared plus 3 squared, which equals 16 plus 9, which is 25, which equals 5. So you take 4i plus 3j divided by 5. All right. So then, writing the vector in terms of its magnitude and direction. So if you look at a vector, whichever direction it goes, there's our vector v, which point A, B. Right, there's our vector v. Here is the angle created, because remember the angle starts with the positive x-axis. So theta is the directional angle for this vector. So notice, remember if we do a right triangle here, that this would be B and this would be A. So remember that cosine theta would be equal to A over the magnitude of V, because this is the magnitude of V right here, this vector. And the sine of theta would equal B over the magnitude of the vector. So, if we were to multiply both sides by the magnitude, we get that the magnitude of V times the cosine of theta is equal to A, and the magnitude of V times the sine of theta is equal to B. So, you know how we had AI plus BJ as a vector. So now we could have the magnitude of V times the cosine of theta I plus the magnitude of V times the sine of theta j as a vector, because those replace the A and the B. And that vector can represent the direction and the speed of an object in motion, and that can be called a velocity vector. So here the wind is blowing at 20 miles per hour in the direction north 30 degrees west. So north 30 degrees west means we go here 30 degrees, right? And we want to find, and the magnitude of this is 20 miles per hour. So the directional angle, if we start from the positive x-axis, goes all the way to here. So it's 90 plus 30. So theta is 120 degrees. So the vector is equal to 20 times cosine 120 I plus 20 times sine 120 j. Well, the cosine of 120, if you remember, is negative 1/2. It's negative because it's in the second quadrant. I plus 20 times rad 3 over 2 j. So then when we multiply, we get negative 10I plus 10 rad 3 j. And that is the velocity vector for this situation. So another one. So here, it's blowing north 45 degrees east, so it's 45 degrees that way, which means that it's also going to be 45 degrees for theta. The wind is 60 miles per hour, so the magnitude of the vector is 60. So our vector, we're going to say, is 60 cosine 45 I plus 60 sine 45 j. Cosine 45 is rad 2 over 2. Sine 45 is rad 2 over 2. So when you multiply, you get 30 rad 2I plus 30 rad 2j. And that is the velocity vector for this particular situation. All right. So then, using this to find the force. All right, so here the magnitude and direction of two forces acting on an object are 70 pounds and south 56 degrees east. So south 56 degrees east is right here. So we're going south 56 degrees east, and it's 70 pounds. And then we have 50 pounds north 72 degrees east. So we have 50 pounds north 72 degrees east. So that means that the angle here, theta, is 18 degrees. And the angle for theta for this one would go all the way around to here. So theta is 270 plus 56, which is 326 degrees for that one. The resultant force, the resultant vector or force, is equal to the vector for one force plus the vector for the other force. So if we call this F1 and we call this F2, we got to find the resultant vector. So for F1, it is 50 times cosine 18.
Did you read that?
50 cosine 18 I plus 50 sine 18 j. And then force 2, you would do 70 times cosine 326 I plus 70 sine 326 j. And so to get the components, you type it in your calculator. 50 cosine 18 is 47.6 I. And then 50 sine 18 is 15.5 j. 70 cosine 326 is 58.0 I. and 70 sine 326 is actually negative 39.1 J. So then when you add those together, it gives you the resultant of 105.6 I minus 23.6 J. That's the resultant vector. Now what it's asking for you in the problem is it says find the magnitude to the nearest hundredth of a pound of the resultant force. So we've got to find the magnitude and the direction angle. So to find the magnitude of this, the magnitude of force 1 plus force 2, remember we can just go 105.6 squared plus negative 23.6 squared. That gives us the square root of 11,708.2. So that gives you approximately 108.2 pounds. That is the magnitude of the resultant force. The direction, there's a couple ways that you can do this. Number one, because we know that cosine theta is equal to A over the magnitude of V. That means that theta is equal to cosine inverse of A over the magnitude of V, which in this case means it's equal to the cosine inverse of 105.6, because that is A in our resultant vector. Sorry about that. Divided by 108.2. So the cosine inverse of this gives us that theta is 12.6 degrees. So the magnitude is 108.2 and the direction is 12.6 degrees. All right, I hope you enjoyed the video, and if there's any questions, please feel free to ask in class as we embark on our discussion about vectors. Have a good evening.